Okay, good morning. So today's lesson is building on all of the data lessons we've done so far. We've done binary, we've done hexadecimal, and now we're doing ASCII. We want to understand what ASCII is today. We need to know what a character set is. We need to know how ASCII works as a character set. And we need to know the limitations of ASCII and how you can overcome them. So we've talked about the idea that computers store both data and instructions. The instructions is like the Python code that you write, and the data is like the variables that you store. And we've said that we can have different data types, like a Boolean, a string, an integer. But you can also have other types of data, like text. And for text to work, you can't store the letter A straight away in binary, because how does that work? You first of all have to give each letter a number, and then convert that number into binary, and then you can store that binary number. So one of the easiest ways to do that is the American Standard Code for Information Interchange. I would remember that because it will come up in your exam. It's American, so it's mostly okay for us Brits, but it's not great for other languages because it only represents American style characters. Irritatingly for us Brits, it doesn't have a number for the Great British pound sign. So you can't represent like £4.50 in ASCII. Why is it necessary? Well, if everybody had their own way of saying the letter A is this in binary, and somebody else had a different way of representing A, when you send an email from someone in one country to someone in another country, you won't be able to understand that email because it will represent the text in a different way. So you have to have a common way of representing every letter into binary. ASCII uses 7 bits, so that's going to be 2 to the power 7. I'll pause the video and somebody can hopefully tell me how many different characters can we have with ASCII. Yeah, so we said it was 128 because it's 2 to the power n, where n is the number of bits. So for us it's 7. 2 to the power 7 means 2 times, so 2 times 2 times 2 times 2 times 2 times 2 times 2, 2 to the power 7, which is 128. There we go. So that means you've got 128 possible different characters, which sounds like a lot, especially considering we've only got 26 in the alphabet, right? But we haven't just got 26 symbols. We've got 26 lowercase symbols, another 26 uppercase symbols, 10 numerical symbols, loads of punctuation symbols, and, okay, we haven't run out yet. We've still got less than 128. But when you start thinking about Japanese kanji or Chinese Mandarin or Cantonese, you're very quickly going to run out. You have not got enough of your 7-bit ASCII to store every single character combination. So there are limitations here. If you try and do a British pound sign, you can't do it in ASCII. If you try and do an E accent, like in French, you can't do it in ASCII. So here's your table. The number in decimal is the same as a number in hexadecimal. Look, that's the table I got you to write out last lesson. 10 is A. We've also got it in binary, like F is 1 nibble, all the 4 bits. I haven't told you about octal, but it's quite easy to work out. It's just using base 8 instead of base anything else. You don't need to know about it for GCSE, so I'll ignore it. For ASCII, you've got all sorts of weird things to begin with, except for a space. That's not particularly weird. Some punctuation, and then numerical values, some more punctuation, some capital letters, some more punctuation, and some lowercase letters. I've had a good question. What does null mean? Null means, well, it's often useful for the end of a string. So if you're representing text in a string and it's like hello, you'd have capital H, which is binary this, and then lowercase e, which is binary that, and then 2 L's, which is binary that, and then binary that again, and then an O, and then that. And then how does the computer know that that's the end of the string and not something else? Well, you put a null, a 0 on it. It just says it's the end of the string. That's how it works in C and C++ and other languages like that. Python hides all of that detail away from you. You don't need to worry. Here's something interesting. A capital A and a lowercase a. Have a look at the binary and see if you can spot the difference. So some people have spotted that to go from a capital letter to a lowercase letter of A, you just have to add 32 or make this bit a 1 instead of a 0. Now, if some of you were wondering why we went from capital letters and then put some weird punctuation marks in there, that's why. It's so that in code it's really easy to do a the dot upper or dot lower that you do in Python, all you do is add 32 or subtract 32, and you can go from either to either. And adding and removing 32 in binary is dead easy. You're just flipping one bit or putting it through a NOT gate. Remember us talking about logic gates? So that's it, essentially. All that you need to know. Where's the Word document? You just need to be able to find an ASCII character, work out what its binary is, what its hexadecimal is, and what its denary is. And I would recommend using this PowerPoint or just searching ASCII table, and you'll find loads of these on the internet, and you can just find out what each of these letters are. This is the same data, it's just represented in a different way. ASCII, because that's how we read with letters. Binary, because that's how a computer understands stuff in zeros and ones. Hexadecimal, because that's a more shorthand way for humans to understand binary. And denary, just because that's how we understand numbers. All right, that's all you need to know to do activity 1. I'll pause the video and resume to give a little bit of help a little bit later. So when you get up to activity 2, you've got 2 characters in ASCII that you have to convert to denary and explain what the difference is. But I'm going to show you how to do this in Python because that will be your extension activity to write some code to be able to convert any character into its ASCII code and vice versa. So let's try and get, oh my goodness, wrong one. Windows 11 trying to be helpful and me not being very clever. Right, so we want to be able to say enter a character, let's just say char, input a character, I'll go for G. And I'd like the Python program to say the ASCII character G is 103 in denary. So we need to do the conversion. So we've got 2 built-in functions. You've got CHR and ORD, and I can never remember which way round it is. But I'm pretty sure ORD will convert a character, a letter, into its ASCII value. So let's just see if that works. If I type in G, great, it's worked. So if we want to get something that will do activity 2 for us, then let's say char 1 and char 2, second character. And then we could do, what can we do? The letter is, oops. Let's see, and then this will have to be converted to a string so that we can display it properly. And what are we displaying? The letter char 1. Let's see, so a G, and then something else. Char is not defined. Char 1, there we go. The letter G is 103. Good. And if you get confused because I'm doing too much in here, you might want to separate it onto separate values. So char 1 as an integer is equal to that. That might be more helpful. I'll leave both of them on so you can see both ways of doing it. The letter, and that needs to be char 2, doesn't it? So I've got a G and I've got an M, char 1 int. Oops, sorry. Then we should be able to do the conversion. So we can say from something to something is something. So you could do that, couldn't you? You could say print from something to something is something, full stop. Something plus something equals something else. Oh gosh, there's a lot of somethings in here, so let's replace them. So from char 1 to char 2 is, all right, and then what do we want to do? Well, I'll let you try and work out the maths here, but it's going to be that minus char 2 as an int, which we'll need to define. So we're taking a long time to do this. We could have just looked it up from the ASCII table, but once we've written it, it's going to save us time later. And then that's the value, but we want to convert that to a string so we can concatenate it. And do I need to say the numbers all over again? No, I can't be bothered, I'm sorry. Let's just say the difference. And stop there. Let's try it. So from G to M is 103, and the difference is 6. And then you can try it again with the character 9, not the number 9, to the character 4, and then the difference is the same as it would be numerically, because they're put in the right sensible order. So that's what we need to do here. Or if you prefer, you can just look at the ASCII table and put in the values and do the maths yourselves. I will leave this code on here if it helps. And the extension here is for you to write the code that lets you do this kind of combination, preferably with this extra bit in here saying something plus something equals something else. So I have made it more complicated than it needs to be. In an exam, you might be expected to do this. You might be given an ASCII value and say, given that the ASCII value for B is 66, work out the ASCII value for capital H. And how can you do that without Python? Well, let's see. Oh, I deliberately sabotaged it, so we're not going to use the Python at all. If we know that capital B is 66, and we know that ASCII follows the same order as the alphabet, then we can just think, right, A, B, C, D, E, F, G, H. H is 6 more characters along in the alphabet than B. So 66 plus 6 is 72. And then from B to H is 6. 66 plus 6 equals 72. That's the kind of thing that we want. So if I unsabotage this and check it, will it work? From B to H. Yeah, it's worked. Good. Okay, so when you've finished, make sure you save this worksheet before you upload it, and then we upload it to Half Term 2 Data 2. This is going to be the last worksheet before the end of topic assessment. So if you want to prepare for the next assessment, you can click on the Data 2 revision quiz. But remember, assessments are not there to stress you out. It doesn't change my opinion of you if you do better than someone else. It doesn't change my opinion of you if you do worse than someone else. They're there to inform you so that you know what you need to revise in future. You know what you can build on in terms of your strengths and what you can address and get support for in terms of your weaknesses. So don't do anything different. Continue with the same amazing work ethic you show every lesson. Don't do loads of last-minute cramming and revision for the tests. I just want to know how much you understand. Okay? So upload the P11 worksheet to Half Term 2 Data 2.